Okay, so we're looking at 5.4, and we're going to be looking at transformations of trig functions, in particular, transformations of sine and cosine functions. Okay, so as a reminder, for sine, what just happened to my camera? I just lost my camera. Okay, so as a reminder, for our sine function, we're looking at a periodic function that begins at 0, 0, ends also on the median line. The middle is also on the median line. First quarter goes up, third quarter goes down. Okay. How would cos be different? Remember, cos starts up at 1, it ends at 1, it goes down in the middle, and all of the first quarter and third quarter are on the median. You will need to know how to label this median line. So in this case, what is the median line? Y equals 0. Okay. All right, so back to our summary. You guys have seen this before, a variation of it when we talked about transformations of other functions. We're just going to apply it now to our sine function. So we're going to start with sine. So given the function g of x equals a, so we've seen the a before, sine, we've seen the k before, mine times theta minus d. So theta is similar to what we saw for x, okay, but now we're using theta because we're talking about angles, minus d, end bracket, plus c. So all of these parameters we have seen before. This is our new function, and theta, though it looks different, is the same as our x, okay? So as a reminder, what does a do to our function? What we saw before is that it caused vertical stretches or compressions. So in this case, it's still going to do the same thing. If a is between 0 and 1, there is a compression. If a is greater than 1, there's going to be a vertical stretch. If a is negative, there's going to be a reflection. Okay? This also helps you determine the amplitude. So remember that the amplitude is the distance from the median line up to the maximum, or the median line to the minimum. You can also calculate the amplitude, max minus the min divided by 2. So I would get 2 times whatever this value is divided by 2. I would get my A value, which is also my amplitude. Okay, so just to give us a reminder of what that looks like. Oops, let me just minimize this. Okay, so let's just take a look at our sine function first. Okay, so here's our sine function. You're going to notice that this is in radians. Just ignore that for now. We're not really concerned about the scale, okay? So I haven't set it in degrees. So all I'm really concerned about is how A affects this curve. So let's watch. Let's have the speed be slower so we can really see what's happening here. Okay, so as my A value is negative, now I have a reflection. So instead of my first quarter going up, my first quarter goes down. Okay, and let's see, let's speed it up a little bit. Otherwise, it might take a while. Okay. Okay, so here, now I'm going into my positives. So you can see when A is 2, I have a vertical stretch. And we're going to keep stretching all the way up until, what's our prediction? When A is equal to 7, what do you predict the peak to land at? The maximum value when A is equal to 7? 7. And what will the minimum be at? -7, okay? So you can see here, if we go all the way up to 7, our peaks will be at positive 7, and our troughs, our minimum values, will be at negative 7. And let's bring this all the way back to when our A value is between 0 and 1. What do you notice about our peaks and our troughs? What is the maximum value here? 0.7. Is this a stretch or compression? Be more confident. Is this a stretch or compression? Compression, because A is equal to 1 is our standard graph, correct? Anything that is between 0 and 1 will be a compression. And you can see that it's going closer and closer to looking like just a flat line. But you'll notice as we hit 0, this is just going to become 0 times sine x, which will be equal to y equals 0. That's just a line. If I continue to go negative, now you can see that I have both a compression and I have a reflection in the x-axis. So you can see my first quarter goes down, my third quarter goes up. Okay, is everyone comfortable with that idea? Good. Any specific questions? So as a prediction, if my A value is this, what will my peak be? Y equals what? 4. What will my trough be? Y equals negative 4. Okay, what transformations just occurred? So vertical reflection in the x-axis and a vertical stretch by a factor of 4. Okay, everyone's good with that? So what do you need to know for your culminating? You will need to know how to graph this. You will need to know how to label the median line. What is it right now? Y equals 0. Okay, a stretch and compression does not affect your median line. What types of transformations would affect your median line? A reflection? Does a reflection affect your median? No. Imagine that this is like the skewer of a kebab, right? So like it really doesn't matter what side the meat or the veggies lie on. The kebab skewer still stays in the middle. Okay? What will change it, and this is what we're going to investigate later, is if we have a translation. Okay, so we're going to get to translation. Before we do that, let's go back to our sheet. Okay, so we've now looked at our A value, so we're good with A. I'm going to skip K for a moment because that is usually the most challenging. I want us to go to D and C. D and C is exactly as you would remember it from all of our other transformations. When D is greater than 1, we move D units to the right. When D is less than 1, we move D units to the left. Same thing with C. When C is positive, we go up C units. When C is negative, we go down C units. So back to my graph here. Let's say that I'm going to start with x minus 5. Okay, so what is my D value right now? Hold on a second. Let me just change this to 5. X minus D. Okay, so right now I have no transformation. Sorry, I should say right now I have no transformation. Okay. If I make D equal to 1, are you expecting to see the graph move to the left or right? To the right. Okay, so you can see that as D increases, we are moving D units to the right. As D becomes negative, we are moving to the left. How would this look? What would the equation of this be? X, would it be minus 5 or plus 5? Try that again. What would the equation, the final equation be? X minus 5 or X plus 5? Ooh, there's a lot of variation in answers here. Okay, let me go back to this one first. What would this equation look like? X minus 5. Because remember, the general equation, like every other equation we've seen, always has x minus d. That's the general equation. So when d is positive, our actual value of d is positive, we're going to see x minus d here. Okay, now it's the same idea, guys. Don't confuse yourselves. X minus d is my general equation. If d is negative 5, that means that my equation here will read x minus negative 5, which will be what? Thank you. Okay, so your equation will look like x plus 5, but you are moving 5 units to the left. Okay, is that better? Good. So let's get rid of our D and let's go to C. Okay, so let's start at 0. That one already showed us, but let's just think about this. If our C value increases positively, what type of transformation will you see? So what type of transformation? Don't just say up. What is that? Vertical? Vertical? I'm hearing different things. Vertical? So we're translating it C units up. Okay? So if C is negative, this is a vertical translation down. So for whatever reason, when we talk about trig functions, we actually have different names for these types of translations. So here, a phase shift is the same as our horizontal translation. So when we have a D value change, we also call this a phase shift. So on your exam, on your culminating, if I ask you determine the phase shift, what I'm really asking you is what is the horizontal translation? Okay? If I ask you what is the vertical displacement, that term just for sine functions and trig functions, I should say, vertical displacement is the same as vertical translation. So for whatever reason, just for trig functions, we have 2 new terms here. Okay, show me thumbs. How do we feel right now? So far, so good? Good. I think we've done a lot of work in this class with transformations. So really, now that we've done the whole course together, do you guys see why in chapter 2 I spent so much time on transformations? That's basically the entire content of this course. So if you feel comfortable with transformations, you should really feel comfortable with your culminating coming up. Okay? So here, just as an example, I'm showing you your sine graph, which you guys are very familiar with, and your cosine graph. Okay, is everyone ready to, oh, I didn't do K. Okay, so back up to K. So remember before, when we looked at K, we always tried to determine the value of 1 over K to look at whether we were having a stretch or compression. Okay, but now in order to determine whether we have a stretch or compression, we're still going to do that, but the period, if there's a stretch, will be more than 360, which is 1 cycle. If there is a compression, the period will be less than 360 degrees, which is, again, 1 cycle. How do you calculate the period? You need to memorize this formula. Okay, I will ask you for this information on your culminating and your exam. You need to know how to calculate a period. Okay, so how would you know what 1 cycle is? Let's say the K value is 2. What's 360 divided by 2? 180. That means the period is now 180. Is that a stretch or compression? Compression. Okay. What happens if your K value is a half? What is your period? 720. Is that a horizontal stretch or compression? Stretch. Good. Okay. Really good, guys. So let's look at that. KX, add a slider. Okay, so let's watch this. Oh, that is going way too fast. Okay, so you can see here, I'm just going to do it manually. Okay, so when k is equal to 1, which is what it always is when there's no transformation, this is what it looks like. Let's move to 2 and see what happens. So just as we predicted, when k is equal to 2, we are doing 360 divided by 2, which is 180. Now my period is 180 degrees. And just so that you have a point of comparison, let's change this to, how do I change the color again, guys? Oh, there we go. Let's make this darker. Okay, so the orange function is our original. So you can see this is what it looks like originally. When my k value is 2, you can see that we are implementing a compression. Does everyone see that? So what used to be 1 cycle, now how many cycles are going to occur? 2 cycles. Okay, so your k value is also equal to the number of cycles that occurred in your original period. Okay, so how many cycles will occur when my k value is 3? 3 cycles. So now you can see I have 1, 2, 3 cycles within a 360-degree range. And going back to here, what would my period be if my k value is 3? What is it? 120 degrees. Okay, and does anyone know what these lines around my k means? Absolute value, which means that even if k is negative, it will still be the same. So let's make k -2. So let's go back to 2. So we know what this looks like. Let's make k -2. All we've done is caused a reflection in the y-axis. So now this is going down and up, because this here, this is actually my first quadrant, third quadrant, first quadrant, third quadrant. So you can see here, again, this is 1 cycle, but what occurred in 1 cycle is now 2 cycles, and my period is 180 degrees. Okay, show me thumbs. Taking this slow, I really want to make sure that we feel comfortable with this. Okay, can we practice a few questions now? And by a few, I mean a lot. Okay, so you are going to become an expert at drawing sine functions. So watch me first and then you go, okay? So 1 sine function, I do beginning and middle, first quarter up, third quarter down. I'm going to do a quick little sketch, and I'm really going to ensure that I have a smooth curve. And just to make sure that we're always practicing this, I'm going to label my function. Okay, what has changed in my equation? A, K, D, or C? A. A is equal to 2. Now on the culminating, I'm not going to ask you what is A, K, D, and C, but you have the right to write as much as you want on that paper. So if I were you on the side, I would write down the A, K, D, and C values so that you can utilize that for your own graphing. Okay, so tell me what type of transformation I'm going to see here. Abdul Basit. Okay, good. What's going to change? My median or my peaks and troughs? And where will my peak be? Excellent. Okay, so the only thing I'm changing are these points here, my first and third quarters. So I'm now going to go up. My median line stays the same. I'm going to go down, back to my median line, up, median line, down. And this is y equals 2 sine theta. Okay, show me thumbs. How does that feel? Easy, right? Good. Half. I have a feeling you guys know how to do this one. Do you want to try it on your own? Okay. Until you feel incredibly comfortable with graphing sine and cosine functions, I still think that you should always draw your base graph. So start with that. And honestly, the only points I need to see are the ones that I'm showing you right now. Median, peaks, and troughs. Okay, Aisha, what is going to change in this graph? A, K, D, or C? A is equal to a half. Who can tell me what is the transformation here if A is equal to a half, Nuha? Good. Yeah, vertical compression by a factor of half. So I'm going to take my peak, and it's going to be at a half. My trough will be at negative a half. Who tried that on their own and got it right? Anyone tried it on their own? Good. Yes, label them. So this is your original is y equals sine theta. Your new graph here is y equals a half sine theta. And of course, you're going to have more room to do this on your culminating. What is the median line here? Y equals 0. Good. Okay, the next one, cos. So where do we start? Where's our first point? 0, 1. So it's up here. Okay, my last point is at 1 as well. My middle is at negative 1. My first quarter is on median. My third quarter is on median. Now, I saw a lot of messy cosine graphs. A lot of you guys saw this and you're just like, I'm going to do a V. No, remember, we don't do Vs. We don't do pumpkin teeth. Okay, what I find really helps is draw 2 cycles just with points. Oops, that's the wrong one. And I find that if you start here, it's kind of like a sine graph. You'll do better curves. Oops, that one wasn't as good. So just as best you can, draw that curve. So negative 2 implies what? Negative tells me I'm going to have a reflection in the x-axis. So I'm going to draw that first. So instead of positive 1, I will now be at negative 1. Instead of negative 1, I will now be at positive 1. If anyone's taking bio, after a while, you'll find that some of these look like DNA. Oops. So I think it's time that we use a little bit of color. Where are my markers? I lost my markers. Okay, so let's do this one. Can you guys see that on screen? The color change? So that's this. Okay. And then my last one, what kind of change am I expecting to see for my next transformation? Actually, let's have someone new. Who's there? What type of transformation from the green graph? So my A value is negative 2. How does the A value of 2 affect my graph? I hear a lot of you guys saying it to me. Do you want to phone a friend? What kind? Vertical stretch. Good. So all of my peaks and valleys will get stretched. And we add another strand to our DNA. Okay, show me thumbs. How do we feel about this? It's good so far? Okay, so here. All right, I'm gonna leave this one for you for homework. Okay, this one right here, that's for homework. I will pick one of these that I'll do with you. Do you want to do sine or cos? Cos, okay. This one's also going to be for homework. What time is it? Okay, so cos, we start at the top, then we go to the bottom, middle, middle. Kyrillo, what type of transformation art do we have here? Say that again? A vertical translation. And remember, vertical translation, when we're talking about sine functions, we call that vertical displacement. I'm okay if you guys don't know that term. Like if you use vertical translation, it's not a huge deal, but just know on the exam, the culminating, I might say to you, phase shift and vertical displacement, and you should know what that means. Okay? Abdul Basit. No, for these ones, you don't really need to draw arrows. It's assumed that it's periodic and it continues. Okay? But the other graphs, I do need you to draw arrows. That one's a little bit more important. Okay, so what does this minus one? Oh, so he said that there's a vertical displacement. Are we going up or down, Kyrillo? By how much? Good. So our median line, so this is how I want you to do this. Here's our median line, y equals 0. I want you to take your median line and I want you to translate that, okay? So now your median line is down here, y equals -1, and you're going to label it. And all you have to do is draw a relative cos function. It's high, high, middle is low, first quadrant, third quadrant on the median. Does everyone understand what I mean by that? So like I have a relative, no? So I want you to ignore the first graph and I want you to see here, I've taken my median line and I've translated my median line down 1 unit. Okay, Rayon, do you see that? So now what I'm going to do is I'm going to say, I'm going to ignore that initial graph and I'm going to think, okay, I'm just going to draw my cosine function, assuming that this was my original median line. So I go up and up at the very beginning and the end. My middle is down. First and third quadrants are on the median line. Okay? Does everyone understand what I mean by that? So it's your relative median line. And I kind of did something similar when we did rationals, right? I said, okay, we have new, pretend that you have new x and y axes. Okay, so here is our final graph. And this one is y equals cos theta minus 1. Okay, so the sine theta is going to be homework, and I want you to do the same thing. Unless, do you guys want to just do it right now for practice? Okay, why don't you guys do these two right now? Show your partner. If you have questions, raise your hand and I'll come to you, okay? I'll pause the recording for now. Okay, so Aisha asked, do we need to have both our original median line and the final median line? You only need your final median line, and that's the one that you're going to need to graph, okay? So label this as y equals -1. This would be y equals 1. So here we have Nuha's graph. She didn't draw her original graph. So if this were the culminating, she would lose a mark for not drawing her base graph. Okay, so you do need your base graph first. I can see that she has y equals negative cos theta, but she hasn't told the reader this because she doesn't have a label. Okay, so Nuha is great at graphing, but she also needs to make sure that she adds labels onto all of her graphs. Okay, so here we have our y equals negative cos theta, and then our final graph here is y equals -1/2 cos theta. Okay, good work. And then same with this, we have sine theta. She does have her original base graph. She needs to label it. And here there's a vertical displacement of 1. And her median line, I would just need to see y equals 1. Okay? Thanks, Nuha. Don't skip steps when you're practicing. All right. So what do we see here? A, K, D, or C? This is K? D. Positive or negative 180? Okay, I want you to draw your initial graph. Don't be lazy with it here, please. Okay, so y equals d means that there's going to be a phase shift 180 degrees to the right. So what I'm going to do is I'm going to imagine that this is my new starting point. That means that somewhere here is my end. This is my middle. First quarter goes up. Okay, now it's really difficult to see this because I'm going in this direction. So you can do one of two things. You can either just track it backwards, and most of you will feel comfortable doing that. If you're not, you can say to yourself, well, I know that my entire period is 360. I'm going to move this 180, but my period will still be 360. So that means this is the end of one cycle, and the beginning of another cycle will be 180 minus 360, which is negative 180. So now this is my first, this is my end, this is my middle, first quadrant up, third quadrant down. So there's a lot of different ways that you could potentially think about it. If it's too tricky for you to think about it that way, you can just follow the pattern, okay, whatever you feel comfortable with. Okay, I'll do one more. So here is my initial graph of cos. Now, some teachers also teach that you can just take every single point and move it 180. Like that's also okay. That's still transformations, right? So here my D value is what? Rwand, what's my D value here? So I'm going to the left or right? By how many units? 90. So again, I'm going to take my starting point, phase shift 90 degrees. So that means my end point is going to phase shift 90 degrees. Now, you can either do what we did before, beginning, end, middle, first quadrant, third quadrant. Okay, so I feel comfortable doing that. Or what you can do is you can literally take every point and move it 90 degrees. Whatever you feel comfortable with. Okay, so do those two graphs. I want to do a little bit of K value today. So these two are going to be for your homework or maybe end of class, but let's skip them for now. Did everyone finish these two? Okay. Yes, which one? Which one? 90? So do you see the initial function? Let me highlight it. Aisha, do you see the initial function? So this is my base graph. I'm going to take every single point and I'm going to translate it 90 degrees to the left. Or I take my first point, translate that to 90, my last point, translate that to 90, and I do what I always do for cos, first point up, last point up, middle point down, first quarter on the median, third quarter on the median. Whatever you feel more comfortable with. Where should my next point be? Here. Does it go up? Does it go down? Does it go way down? Where is it going to be? On, well, this is all 360. Is it on the median, peak, or trough? Median, good. Okay. Can I flip to K value? Would you rather that I don't do K value yet and I leave that till tomorrow? Okay. If that's the case, I don't mind. I want you guys to do both of these and show them to me before we leave today. Okay? Both of these. Okay, so we wanted to review this one again. So here is my y equals sine x, or in this case, sine theta. So again, we are translating or having a phase shift of 180 degrees. So 180 degrees means that this point would now be here. This point would now be here. This point would now be here. So this is the beginning of my next cycle. Now, if you feel comfortable, you can just continue the pattern backwards, okay? Or you can take another one of your points. You can take this point and you can translate that 180. You can take this point, translate that 180, this point here, and so on, okay? So you can just take all of your points and translate them 180 degrees to the right. Does that help? Okay, great. And label it. I didn't label it, but you guys label it. Yes. Okay, good question. You must, things that I want to see on your graph. Do you need to put on arrows? Not for trig graphs. It's the only one that I don't really need to see it. Some teachers require it. I think it's pretty clear that it's continuous because it's periodic. So I'm going to say no, you don't need to put arrows. Do you need to span the entire axes? Yes. Okay, you too? Did you hear what I said? You need to span the entire axis. So don't just give me one cycle. I want to see that you're able to continue the cycle entirely, okay? I always need to see your median line labeled if it changes, okay? Let me just pause this. Okay, so we have Nuha's graphs again. She's redeeming herself. She's labeled everything, including the median line. Okay, so this is the solution for the last two graphs. Okay, and just to be clear, what I'm gonna do, can I write on your piece of paper, Nuha? Okay, so this is her original graph, y equals sine theta. This point has translated 270 degrees to the left or right? To the left or right? Left. So now it is here. And then this point had a vertical displacement of 1. Now it is here. So just to show you where that point goes, you might want to make it a little bit larger for yourself. I'll do the same thing here. So here's my initial point, 180 degrees in which direction? To the right. Now goes here. This C value of -1, now this point goes down 1 unit. Does it help to see where the translation goes? Okay. Any last questions? Great. So tomorrow we'll continue and we'll work with K. Did you say yay?